So, Mr. Rudra, a small spherical ball of radius r falls with velocity v through a liquid having coefficient of viscosity neta. Find the viscous drag on the ball, assuming it depends upon neta, r, and v. So, Mr. Rudra, we'll start with the basic equation that the viscous drag, the drag force, will depend upon some constant k that I'm not aware of, but they have said that this k is equal to 6 pi. So once I've derived the expression, then I can put the value of k here. So this force depends upon the radius r raised to power some value, the velocity v raised to power some value, and coefficient of viscosity neta raised to power some value c. And now using dimension analysis, I need to find the value of a, b, c. So one confusion that usually students have is that, can I write this? Do I have to write it like this also, or only? Can I write this like, let us assume like this? Of course you can. It doesn't matter, because once we solve for the values of ABC, accordingly the values of ABC will come as per the equations that we have made. It doesn't matter. So I can have r raised to power a, or I can have r raised to power, I'm sorry, this is r raised to power c. So I can have r raised to power c, or I can have neta raised to power a. It doesn't matter. Once I solve for the equation, the value of ABC will come. Yeah. So now let me look at the equations that I can form. So the equation that I can form would look something like this. So for example, in this case, I've taken this value, v raised to power a, neta raised to power b, r raised to power c. So it doesn't matter in whatever form you can take. Now, I know the coefficient of viscosity neta is m raised to power l, 1, l raised to power minus 1, t raised to power minus 1. So this is my coefficient of viscosity. And, when we enter class 11th, we are not aware of this coefficient of viscosity. But what I'm trying to tell you is that once we have derived this formula, then we'll try to understand how the coefficient of viscosity is this. So let us assume that, let us go with the flow, and let us assume that the coefficient of viscosity is m raised to power 1, l raised to power minus 1, t raised to power minus 1. And one thing that you need to keep in mind is that, again, when we are in class 11th, we are not aware of, we might not be aware of you. So for example, in this case, I'm not aware of the coefficient of viscosity. So what I need to do is, in my textbook, I'll have a chart like this. So for example, if I need to find the coefficient of viscosity, elasticity, so I'll look at this table, coefficient of elasticity, and I will find this chart, m raised to power 1, l raised to power minus 1, t raised to power minus 2. So at least गाड़ी चलाने के लिए, this is the thing that I have. So in all the textbooks, they have this chart. In NCERT book, this is part of the annexure. So I can look for, so for example, coefficient of viscosity. This is the m raised to power 1, l raised to power minus 1, t raised to power minus 1. So when I'm doing any practice question and I'm not aware of any MLT of a certain physical quantity, then I can refer to this. So for example, let us take some weird example. So for example, I'm not aware of permittivity of free space, or I'm not aware of relative permittivity or dielectric constant. Then I can look at the annexure, and I can hope and pray to God that if my teacher gives this question in the exam, he will provide me this MLT. But usually in class 11th first term exams, they will give you all the question from which are basically depend upon formulas which you have done in class 8th, 9th, 10th. 90% of the times. Okay. So this annexure is part of every textbook in NCERT also. This is part of the annexure. Yeah. Okay. So let us assume that I know coefficient of viscosity. I've seen the table, and the coefficient of viscosity is m raised to power 1, L raised to power minus 1, T raised to power minus 1. Okay. Now, uh, of course, I am supposed to know the this, at least I should be aware of that, how to write the MLT notation for velocity. It is meter per second. For neta, I have copied from the measure, and from radius, this would be distance. So that is why m is 0 and t is 0 and L is raised to power 1. So right hand side, this would be raised to power A, this would be raised to power B, this would be raised to power C. This I'm aware of. And when I look at the left hand side, force. Now, see, I'm the kind of person who doesn't, I can't cram many things. So what I usually do is I'll derive the MLT notation. I know the formula of force. Force is mass into acceleration. Mass is kg. Acceleration is meter per second square. So in terms of this MLT notation, I can write the MLT notation for force as m raised to power 1, L raised to power 1, T raised to power minus 2. I've derived this. So my left hand side would be m raised to power 1, L raised to power 1, T raised to power minus 2. And on the right hand side, whole of this Mahabharata is there. Yeah. And now I know I can form three equations from this. One would be for mass, one would be for length, the third would be for time. So when I compare for mass, so mass is 1 is equal to, I don't get anything here because there is a 0 here. I get B here. I get B here. And again, I don't get anything here because mass is raised to power 0. So from first equation, I get my P is equal to 1. This is the first equation I get using my mass equations. Then I focus on the length. Length is, this is 1, and that is why this is 1. This is A, this is minus B, and this is C. So A minus B plus C is equal to 1. This is an important question both from, exam point of view, and I consider this important because anyways in semester 2 you will be doing the derivation of this again. So this is the second equation that I have, and from my third equation, that is my time equation, what I'll get is minus 2. This minus 2 would be equal to minus A minus B, and I will get nothing from here. So A plus B is equal to 2. So this is the equation that I've got. Now, it depends upon how good your maths is. So B is equal to 1. Now B is equal to 1. So if B is equal to 1, then A would be equal to 1. Now B is 1. A is 1. So C is 1. So the formula would be F is equal to K V neta R, and this K I'm given a value of 6 pi. So this formula would be 6 pi V neta R. Now let us dissect this further. So let us dissect this further. So my force is equal to 6 pi neta R V. So the drag depends upon the coefficient of viscosity, how viscous the fluid is, radius of the metal ball. I think there is an experiment that you will also do based on this. Usually what they do is, I don't remember whether this is part of the 11th, 12th syllabus or not, but in engineering we did this experiment. So what they do is, uh, there is a there are two, three fluids which are given to us. So for example, some you can take water, you can take kerosene oil, then other some engine oil or something. So depending upon the fluid, the coefficient of viscosity will vary. Then I have that this metal ball, steel ball. So I'll have the radius of the steel ball. To calculate the velocity, what I do is I mark these points, and then using stopwatch, I calculate the velocity at which the metal ball falls. Is it clear? So this is the experiment which we used to do. I don't know whether now it is in part of 11th, 12th or not. So now I want to see this I want to analyze this for the units of coefficient of viscosity. A 6 pi has no units. So this is kg meter per second square mass into acceleration upon 1 upon meter upon meter per second. So this second, and this is, I can write this as m l minus 1 t minus 1. So the coefficient of viscosity is m l minus 1 t minus 1. Is this the is this what we had used? Of course, this is what we had used. M raised to power 1, L raised to power minus 1, T raised to power minus 1. So, as a matter of fact, you will be using this anyways. So, it helps to, remember this formula. So, force is equal to, drag force is equal to 6 pi neta RV. Coefficient of viscosity into radius of the metal ball multiplied by velocity. If you just want to, if you want any mnemonic advice, mnemonic device or something, of course this is not mnemonic, this is practical also. So when your car is, the next time you are sitting in the car, if you take your hand out, you will feel a drag force. That drag force is given by this formula only. So this, in this case, roughly radius would be the radius of your palm, roughly speaking. V would be the velocity of the car at which you are moving. So at more velocity the car is moving, the more drag force is there. You can take your hand out, you can take your dog out. Yeah. So your dog would have more drag force because the area is more. So neta coefficient of viscosity is the how viscous the air is. So it has a practical implication also. So force is equal to 6 pi neta RV. Now another thing that you need to do as homework, you can do it on Wednesday, when Wednesday is you are taking a break on Wednesday. So from question number 8 to question number 14, question number 8, 9, 10, 11, 12, 13, 14. So you can do these as homework, and I have already sent you these solutions. So this is question number 8, question number 9, question number 10, 12, 13, 11, 14. So you can check your answers. Actually, the answers are given in the question, but if you just want to match the equations, if you want to match the equations, so answers are given in this PDF. So if you see, all the answers are given. But if you want to tally the equations, then you can refer to the solutions. They have solved few questions here, but there are 2, 3 questions which they haven't solved. Then you can tally from these nodes.